This is the fourth video of the lecture series, Business Forecasting, and we were discussing time series analysis, and this video is about simple exponential smoothing. So before discussing the agenda, I must tell you that in case of time series analysis, our approach is hierarchical in nature. So first of all, we will see the simple exponential, simple moving average, which we have already discussed, and then weighted moving average, and next is simple exponential smoothing, then the Holt's method, and finally the Winter's method. Now, since this video is about exponential smoothing, that means simple exponential smoothing, this one, we cannot discuss it before discussing the weighted moving average. So first of all, the first agenda is to discuss the weighted moving average, and then only we will see how the simple exponential smoothing expression is derived from weighted moving average concept only. Okay, once this is done, we will implement the calculation using the Excel spreadsheet, and then after that we will discuss very briefly about the sensitivity effect of the smoothing constant of exponential smoothing on the sensitivity of the forecast, and finally we will discuss the advantages and disadvantages of exponential smoothing and close the video. Okay, so first of all, let us see what is a weighted moving average. So in the last video you have already seen how to calculate the moving average, simple moving average. So let us take the example of MA3, that means moving average, simple moving average of order 3. So that means we are averaging the last 3 actual values to get the forecast of this particular, the most recent period. Okay, so if you have not seen this video, that means the video regarding a simple moving average, so go back to video number 3 in this lecture series and watch that before coming back here. So once this is done, you can see that this expression can be also written in this way, like it is divided by 3, so I can take 1 by 3 as a coefficient to at minus 1, at minus 2 and at minus 3. So this becomes a weighted moving average where the weights are actually same. So therefore moving average, simple moving average is a special case of weighted moving average where the weights are equally distributed. Now therefore let us come to the weighted moving average. Now we are only discussing about order 3, so we are not complicating things, just trying to understand the weighted moving average in terms of order 3 only. So in case of moving average, the weight was 1/3, 1/3 and 1/3 in all the 3 actual values. Now in case of weighted moving average 3, we may have different weights, that means Wi, W1, W2 and W3, with a given condition that the sum of these weights must be equal to 1 and the weights will lie within 0 and 1. So the weights are positive fractions and the summation of these weights must be equal to 1. So for example, this is an example of moving average of order 3. So if you take the example of WMA4, fundamentally nothing changes, only we will have at minus 1, at minus 2, at minus 3 and at minus 4, and therefore you will have W1, W2, W3 and W4. So 4 weights will be there, but this is order 3, so we have taken 3 weights. So if it is W4, WMA4, then the sum of weights W1, W2 plus W3 plus W4 must be equal to 1. So simply speaking, the sum of the weights should be equal to 1 and the weights should lie between 1 and 0. So that is all about weighted moving average. Now let us see how to interpret the simple exponential smoothing in terms of weighted moving average. So as it is written here, simple exponential smoothing is nothing but a version of weighted moving average only. But although it is a version of weighted moving average, there are certain differences. So first of all, the weights are not discretionary, which means in case of weighted moving average, we used W1, W2, W3 as per our wish. So you can have various values of W1, W2, W3 as per your choice. There is no problem. But in this case, that will not happen. The weights has to be taken in an exponential manner. How to take the weights, that we will see just now. So, and secondly, the weights will apply to all the historical values. So for example, WMA3, if you take the example of WMA3, you need to put the weights to the last three observations only, the last three actual observation. If it is WMA4, then the last four observations, like that way. But in case of exponential smoothing, you do not have anything like exponential smoothing, simple exponential smoothing of order t. Nothing like that exists. So what exists is, for any simple exponential smoothing, it is automatically understood that you have applied the weights to all the available data in the history. So that is the second difference. And what is the third difference? It is little difficult to interpret and understand, but I need to state this here, that this expression of the simple exponential smoothing forecast is dependent on an assumption that the weights have been put until the infinity, that is the very beginning of the time series. So you may ask that how can you perceive infinity from a finite time series analysis? So that is a question that has to be answered, but let us now assume that the weights are given until up to the infinite beginning, and that is how the expression has been derived. So let us again see the formula for weighted moving average. So Ft is equal to W1 AT1 into AT minus 1, W2 into AT minus 2, W3 into AT minus 3. So now the simple exponential smoothing formula is a little modification of this formula, where the you see the W1 weight has been transformed as alpha. W2 is alpha into 1 minus alpha. W3 is alpha into 1 minus alpha whole square. So, and here the alpha values are lying between 0 and 1. And this alpha is called the smoothing constant or the smoothing coefficient. Alpha is called the smoothing coefficient, whose value is will always lie between 0 and 1. And as you go back in the time series, that means in the most recent time series, you will have the weight is equal to alpha. The next one will have the weight is equal to alpha into 1 minus alpha, and then you will just square the 1 minus alpha term until the infinity comes. So that means this is this is a series that will continue up to the infinity. So now let us transform this series and write this in terms of t minus 1. So just replace t by t minus 1. So suppose this is your equation 1 and this is your equation 2. So there is no difference between 1 and 2. Only thing is you have replaced t by t minus 1. So as you have replaced t by t minus 1, then t minus 1 becomes t minus 2, and t minus 2 becomes t minus 3, and so on. Now in the next transformation, you have multiplied this equation 2 by 1 minus alpha. So equation 3 is nothing but equation 2 into 1 minus alpha. See, this is just simple multiplication in both the sides. So I have multiplied the entire equation in both the left hand side and right hand side by 1 minus alpha. So now in the next step, what I will do is I will subtract 3 from 1, equation 3 from equation 1. So you can see this is Ft, and this is 1 minus alpha into ft minus 1. So I have simply subtracted 3 from 1. So in the left hand side, 1 minus alpha into ft minus 1 is subtracted from ft. Now once this is done, I will also perform the same calculation in the right hand side. Now check carefully this particular part of the equation and this particular part of the equation are the same because they extend to infinity. You can check here, these two are exactly the same. So therefore if you subtract the right hand side of equation 3 from the right hand side of equation 1, what to get is only this term. That means only this term. So this becomes your formula for exponential smoothing. So if you just do just little modification, the formula becomes this, and this is the final formula that we will be using in the spreadsheet also in order to calculate the exponential smoothing forecast values. So now since we have derived the formula, let us move on to the Excel sheet and implement this formula for a particular set of fictitious data. So this is now the Excel sheet. You can see these are the actual values. So actual value is 80 and the forecast is FT. So the forecast, the same equation that I have shown you in the slides, is written here, and I have chosen the smoothing coefficient alpha is equal to 0.35. At this point of time you can choose any value of alpha as you wish. So I have taken 0.35. Now please remember that it is also possible to find the best value of alpha, that is optimal value of alpha, for a particular forecast, but we are not discussing it right now. We will see it later on, how to optimize the value of alpha. Okay, so first of all you see that we need to find the forecast of period 1, but to find the period 1 according to this formula we need to know the value of period actual value of period 0 and the forecast of period 0, because t minus 1 is required, but you don't have any value for period 0 and therefore you cannot calculate ft value for period 1 in using this formula. So what to do? So it is customary to take the first period value equal to the actual value in case of exponential smoothing. So this is called initialization. This process is called initialization process. Some books and texts actually also use the averaging method, that is instead of taking the first 80 value, they take the average value of the entire time series in order to initialize. That is another method, but that is not very common, or that is also again not necessary, as it is unnecessarily complex. So we will take this particular mode of initialization, that means that we will take the first period value as the forecast value and then move on to the next period, that is period 2. So use this formula now. Alpha is 0.35, 0.35, that is placed in B1. So B1 into AT minus 1. What is AT minus 1? In this case AT minus 1 is A1. So this one plus 1 minus alpha again, then 1 minus alpha into ft minus 1. What is ft minus 1? This is f1. So this one. So let us look at this formula once again. So b1 is alpha into b3. What is b3? b3 is 80 minus 1. So we are in month 2. So we are calculating this value which will give us f2. So in order to calculate f2 we need to have the values of a2 and a1 and f1. So a1 is 24 and f1 is also 24. So b3 is A1 and C3 is F1. So in this way this formula is written here. So once this is done, you can enter the formula. Also please note again carefully that I have not only written B1 here but also included this dollar sign. What is this dollar sign? You, if you write B1 here and then press F4, then it becomes $B $1. What is the purpose? Because purpose is, if you just copy it down, then what happens is in the next row this B1 value does not change. So we want the alpha to be constant in all the form, all the expressions. So we need to fix B1, and that is why we are using $B $1, which is possible if you press F4 from your keyboard after selecting B1. You don't have to actually select B1, you just type B1 here and then put your cursor between B and 1 and then press F4. So it becomes $B $1. That is what is required. So in this way you will calculate the forecast for all the period, and then you can forecast for period 8, which is the 1 period ahead forecast. So again similar to moving average, simple moving average and weighted moving average also, you cannot actually confidently forecast for more than 1 period ahead. So this method is good enough for only 1 period ahead forecast, and still if you need to forecast more than 1 period ahead, so you know what to do. I have discussed this in the moving average video. You take the same forecast down to the more than 1 period ahead also. That means you take the flat forecast. Okay, so this is the implementation process of simple exponential smoothing. So let us come to the slide once again. So now I need to mention the choice of alpha. So how will you choose the alpha values? So as we have discussed that alpha will lie between 0 and 1, but which value will you choose? Like you can choose the value towards 1 like 0 0.8, 0 0.9 or 0.7, or you can take the value towards 0, that means 0.1 or 0.2 or 0.3, like that, or you can choose to be in between like 0.5 or 0.6. So what will you do? That is the question. So the answer to this question is, when you reduce the value of alpha, so you reduce the value of alpha, that means you are going towards this zone, so your reliance to your past data increases. So as you reduce the value of alpha, your forecast is now more reliable on the past data, and the responsiveness of the forecast becomes less. That means I have already discussed this point all in the moving average video, but in terms of alpha here also, if you take a larger value of alpha, then if in your recent period, if some actual value changes, then the forecast will rapidly change. But if your value of alpha is very small, like towards 0.1 or 0.2, then your forecast value is dependent on the entire time series from the beginning, and therefore only changing a single value of your actual figure will not change the forecast value, and in that way the forecast becomes less responsive. Another way of saying this is another way of saying this is the forecast is less sensitive to recent changes. So you reduce alpha, your forecast become less responsive, like more rigid forecast. Anything happens in the recent data, like some changes in recent values, your forecast will not change that much. If that is your requirement, then keep your alpha value towards the lower side. But if you think that the more recent observations are more important, and any changes in more recent observations are to be included in the forecast, that means the forecast should reflect those changes also, then you should keep the alpha values towards the higher side. So in this way you will choose the value of alpha. And finally, if the objective is to minimize the error, we have not discussed forecasting error until now, but we will discuss at some point of time. But just to mention here that if your objective is to minimize the value of error developed by the forecast, then you need to optimize the value of alpha. In that case, your alpha can fall in any zone. The idea will be to minimize the total error. So in this way, we will choose the value of alpha. And then finally, the advantage and disadvantage of exponential smoothing. It is sometimes, the advantages are, it is sometimes more accurate compared to the moving average, where the trend is not present, and it is little more adaptive compared to the moving average, because you are given a particular parameter alpha which you can vary, and then varying the parameter you can make the forecast little more adaptive. And among the disadvantages, it is the same disadvantages are there uh, compared to moving average, that is it will underestimate or overestimate depending upon uptrend and downtrend, as I have discussed already in the moving average video. And also sometimes it is like more complex, and the benefit of this complexity is not at all realized in many cases. So you can see that you calculate the moving average forecast, you choose a particular value of moving average, say MA3 or MA MA4 MA4 or MA5, any of these, like at least one of these will be found better than your exponential smoothing forecast. So the question is, then why should I use exponential smoothing forecast if MA 3 4 5 or any other MA of your choice gives almost similar or sometimes better than better accuracy than the exponential smoothing forecast? So sometimes it becomes a little complex for no reason, no benefit. So that is one disadvantage that is sometimes observed. So that's all about exponential smoothing forecast, nothing more to say. And in the next video we will discuss the double exponential smoothing method. So until then, thank you and goodbye, and thanks for watching this video.